So one of the first questions is there a way to automate control of the dosage? So the first question, yes, there is a way to control, automate the system. And so if you go back to what Joe talked about in the video, we'll have a generator. That generator outputs an oxidant. Most customers take that oxidant and put it in a storage tank. And so the generator is actually controlled directly by that storage tank. As the storage tank level falls, the generator turns on and fills up the storage tank. From the storage tank into the application or into the dosing, we do have a number of customers that use both ORP and chlorine monitors to automate that control. So that if a certain ORP is desired in a recirculation loop, you can simply tie that back with a 4 to 20 signal to a chem feed system that will dose in the right amount of oxidant to maintain that ORP. Same thing with a chlorine residual. If you're trying to hold a 1.5 milligram per liter chlorine residual, we can simply automate a pump back into the tank, and the tank injecting into the system is independent of the tank being filled by the generator. So hopefully that answers the question. So next question, there are two versions, a mixed oxidant version and one that generates bleach. The answer to that question is yes. As I mentioned earlier in our discussion, MIOX does have two different electrolytic cell designs. One is optimized for the lowest cost output, and that output is sodium hypochlorite. The second generator, or the second electrolytic cell, has actually been optimized for superior biologic control and biofilm removal. We actually term that generator and the output from that generator mixed oxidant, and so we can differentiate between the two. So we do have a generator that simply produces sodium hypochlorite, a direct replacement for bleach, and a second generator that produces a mixed oxidant that is still mostly sodium hypochlorite, mostly bleach, with some other trace oxidants. And those other trace oxidants are the ones that actually give that superior biologic kill on difficult organisms such as Giardia or Cryptosporidium, and also brings the benefits of the biofilm removal. I got a question on what's the difference between MIOX product and commercial bleach. Commercial bleach typically sold in a lot of different forms, but the primary forms in volume are either gas or as a liquid sodium hypochlorite, which typically is 12%. And so that if you have a customer that's buying another form of bleach today, at least in large volumes, more than 500,000 pounds a day, they'll probably be in one of those two forms. MIOX can offer benefits for both. Just 2 weeks ago, I was in Bogota, Colombia, where we have one of our larger installations. And at that facility for years, they've always been using gas chlorine in large 1-ton cylinders. And the municipality recognized that as a potential risk both to their employees and the surrounding community. It's a very large system, 30, 40, 50 million gallons per day of treatment, depending on the season. So in the warehouse that I was in, they must have had storage capability for 50 1-ton gas chlorine canisters. And they've now shifted a third of their production to on-site generation, where they simply store bulk salt. They have a tank of salt that makes a brine solution, which obviously is much safer than the solution they had. So that's how we would compare to gas chlorine. Liquid chlorine is a little different. It does come in a liquid form. It is stabilized at a higher pH. And so as I mentioned earlier in the webinar, bulk hypochlorite does have an issue with breaking down over time, especially in elevated temperatures. And so caustic is added to elevate the pH to try and slow that degradation. That's actually a big advantage of the MIOX technology, because we produce on demand that day only the oxidant that's consumed, and so we don't have an issue with storing it. So our product is actually at a more neutral pH. It still is elevated above neutral, but not nearly as high as the bulk solution. In addition, because we're generating on site and not transporting the chemical, we can produce at a lower concentration. So we produce between 0.5 and 1% solution of bleach. So that would be the other big difference between commercial bleach, which if you're needing to ship the product would be a disadvantage because you'd be shipping more water. But because we're simply putting it in a tank and directly injecting it into the system, it's a big advantage. I get another question of what is the maximum pH of these units? And I assume what the question has to do with is actually what is the maximum pH we could inject the solution into and still have effective biocide removal. And I guess I'll answer that in that we don't have a specific number, but we do have experience that our product, especially the mixed oxidant, the cell that's optimized for biofilm removal, actually does better than other forms of bleach at elevated pHs. And so, for example, if you're looking at a cooling tower application and the customer required bromine as a secondary disinfectant, we've actually had success replacing a bromine-chlorine combination that was being used because of elevated pH. And so if you have a specific number, feel free to contact us, or a specific application. But I can say that we have a number of installations that have proven that the MIOX chemistry generated on site is more effective at elevated pHs than other forms of bleach. I have another question. A customer is already using on-site generation, another unit, but are still having persistent issues with disinfection byproducts. Would a change to MIOX benefit? The answer to that is maybe. So disinfection byproducts, for those of you that aren't familiar, are formed when an oxidant has time to react with an organic substance. That organic substance in municipal water treatment typically comes from one of two sources. If it is a surface water plant, very often the organic substance is coming from the surface water. It's a breakdown of organic materials, acids, tannins, etc., that are forming an organic that then is reacting with the primary disinfection technology that's being used, very often chlorine, and can create disinfection byproducts. So if the organic substance in this specific example is coming from the surface water, then the answer is no. A MIOX technology probably would not be any different than another on-site generator. However, the second area we've seen extensive and potentially more issues with disinfection byproducts is in distribution. So after the water is treated and the primary dose of oxidant, bleach, chlorine is used, and the water has time to react out in the distribution with the organic material, that is where the disinfection byproducts often come from. If that is the case, then yes, a switch to MIOX could dramatically improve the situation because the MIOX chemistry, the mixed oxidant chemistry, has shown very effective at removing biofilm. And so if the customer was to switch to that chemistry and the biofilm was stripped off, you've taken one of the two elements of the disinfection byproducts away. You've taken the organic material away, so it would potentially reduce the disinfection byproducts. We've actually got an interesting case study that was written up, I think in 2008, on a city in South Carolina that had that exact problem, and we're having disinfection byproducts issues not at the facility, but at the furthest points of distribution, and after the switch to the mixed oxidant chemistry alleviated those issues. I got a question on MIOX chemistry and our experience with Legionella. And it's actually very related to the last discussion, or the last question we talked about with distribution piping. Legionella or Legionnosis bacteria is actually relatively easy to kill with an oxidant. The issue with many customers, though, is that the oxidant doesn't get a chance to come in contact with that Legionella. And so, very often chemical service providers will recommend multiple oxidant or a multiple biocide approach to Legionella control or risk management. And the reason often is that they're trying to prevent that biofilm buildup. And what the industry and users have found is that if they change the biocide chemistry, they can actually prevent some of that biofilm growth where the Legionella perhaps is embedded so that it can't get in contact with the chlorine. The MIOX chemistry does the same thing, but with less cost and more easily, because we can remove and control biofilm without multiple chemistries. We wouldn't need a mixture of chlorine and bromine with a periodic surge of isothiazolene, for example. So we have a number of case studies also on our website, and certainly that we can send if you request, of Legionella control, typically in hospitals. We've done, at least a dozen hospitals in the last few years where the primary requirement was better Legionella control. Got a question from how stable is the oxidant? Good question, and I guess I'll answer it for two ways. One, with the straight sodium hypochlorite product, our output will have no more or less stability than standard industrial bleach. We might have slightly better stability because we're at a lower concentration. So if you had 2,000-gallon tanks, you filled one with MIOX, sodium hypochlorite on-site generated, and the other was full of industrial bulk bleach, you may see slightly lower degradation in the MIOX, but it would probably be due to the dilution factor more than anything. The mixed oxidant, that's also a question we get. The cell that's optimized for that superior biofilm removal and biologic efficacy, that does have a shelf life. And so what happens is, because we're creating multiple oxidants, they actually will react with each other over time. And so when customers are really looking at biofilm removal and that efficacy as the goal, we'll work with them to minimize the size of that day tank and really make sure that they're filling it at least once a day. Because the mixed oxidants and the beneficial attributes you get from them do degrade with time relatively quickly, a couple days. So we definitely want to make sure our customers are making and using the mixed oxidant chemistry. Now, the mixed oxidant chemistry doesn't go back to water. You simply end up with sodium hypochlorite. So those other beneficial oxidants are the ones that are consumed, and you end up with a standard solution of sodium hypochlorite, but you don't get the benefit that maybe they were looking for with the mixed oxidant. The next question was about concentration in the storage tank at 0.8%. 0.8% is the output of the sodium hypochlorite cell, the cell that we've optimized for reliability and cost. So the output of that cell would be at 0.8%. And I would say that it'd be very likely that the tank is held at 0.8% as long as it's filled regularly. But if you had a system, for example, that filled the tank on a Monday and no oxidant or very little oxidant was used until Friday, it would not be at 0.8% any longer. Just as industrial bleach, you get some degradation over time. But that is one of the big benefits of the on-site generation technology, ours or anybody else's. You can make and use the oxidant, the bleach product that you need on a daily basis. And so as long as the system is designed right as far as how much oxidant is made and used each day, then yes, the tank would stay very close to that 0.8 output percent. So we get a question with what does water with silica cause, or does it cause issues with the generators? The answer is probably not. We've not done extensive research yet on silica specifically, but because silica is not ionized, unless you get to very elevated pHs, in general the silica will pass right through the generators. The issues that we have are more on divalent, trivalent salts and metals. Because we're running a very high electric field, the metals that carry a +2, +3 charge are the ones that tend to scale out first. So unlike on a membrane system where you're actually concentrating the solution and you reach the saturation limit of silica or calcium sulfate, scaling in an electrolytic cell is a little different in that it's driven by the electrolytic charge or the charge difference. That is another technology innovation that MIOX has brought to the market, is we actually have the ability to reverse the polarity. So if we were getting calcium scale, for example, on one of the electrodes, we would reverse the polarity and drive off electrically that scale formation. So most of the scale that we see on cells that have not been run properly tends to be calcium or magnesium based. So hardness is the one that we'll monitor much more readily than silica. Next question I got was, is it possible to use a different kind of water for the brine solution? Great question, and a relatively new development in the industry, and we believe that MIOX is one of the few companies that's pursuing this avenue. But I can share with you that we are in the process of doing some technology innovation looking at alternate brine sources or waste salts. We do not have a product that's commercialized today, but hopefully we'll be doing a MIOX 202 webinar in the near future, and I'll be able to share with you some more of those details. But if you remember, I talked about MIOX's core technology, and where I see the most benefit that we can bring to the market, it is on the technology around the electrolytic cell, and we are extending that technology to look at how could we run a reliable, cost-effective unit on a lower cost brine source, or potentially even a waste salt that had a lot of other concerns for most vendors. So more to come on that one. All right, next question. What are the typical O&M costs per gallon of water? That is a question I don't have an answer to. We do have a pretty good idea of kind of the cost per pound of output, and in most cases we're competitive with delivered bleach in the, let's say, $60 to $1.20 per pound basis. And so that would be actually taking the capital amortized into the cost. If you were to take the capital out of the O&M cost or the operating cost of a MIOX generator, your primary cost is electricity. And almost all of our customers, their largest operating cost will be electricity. So if they're paying 6 cents or 26 cents, that really drives their operational cost. The next biggest operational cost is salt. And again, are they paying 15 cents a pound, 5 cents a pound, or 35 cents a pound will dictate that O&M cost. So we've got some great calculators that we can share with you that will give a real specific number for your case. But in general, depending on the output chemistry and the cost of electricity and salt, as I said, total all-in cost runs, 60 cents to $1.20 per pound. Take the capital out of that, it might be 40 to 80 cents. But again, it's very dependent on your electrical and salt cost at your specific location. The next question is, which is the better total oxidant, mixed oxidant or bleach? And I would say that that is a question for the customer, because the customer will need to decide which is a better product for them, where they're focusing on cost or they're focusing on some other attribute of the oxidant. We have a number of installations where the customer was using bleach and the bleach wasn't meeting their goals. It wasn't controlling the algae, it wasn't controlling the biofilm, it was too expensive or too hazardous to transport and move. Then, we would recommend, a superior form of bleach. If the interest, though, is simply the lowest possible cost chemical or the lowest possible cost form of sodium hypochlorite, then the output of the generators that are optimized for cost are better, because you can actually lower that cost per pound, that cost per output, and the same electrolytic cell will actually give you more output. So the question of which is better is really driven by the customer. What are their needs? What problem are they trying to solve? This is another area of innovation that we're working on. Again, part of the MIOX 202 that we'll do later this year. We're looking at what other oxidants we could potentially make from the electrolytic process and look for some other real specialty applications. I got a question for how long does it take for the mixed oxidant to degrade back into standard sodium hypochlorite? That's actually very temperature dependent, but what we'll recommend to our customers is somewhere in the 30 to 40 hour kind of time frame. And so again, it goes back to design of the system. You'll want to make sure that your brine tank and your electrolytics output tank, the oxidant tank, are sized such that you use that oxidant in less than a day. So that if the usage at that 1%, at that 0.5% concentration is 600 gallons, put in a 1,000-gallon tank, not a 5,000-gallon tank, to make sure that you're using the mixed oxidant in still the mixed oxidants form. Another question we got, is MIOX compatible with generating chloramines? And that is a complicated question to answer. In general, I would say that we have some experience with doing that, but that it's a quite complex issue to do blending effectively on site, and so still in development. But certainly we're down that path, and if you have a specific application or interest, we'd be happy to talk more details with you about the disinfection goals, why the customer is looking at chloramines versus another form of oxidant. But it is something we've started and something we're confident we could get to, but we'll take a bit more time. The next question is about operator training and operator experience. Specifically, would the units be appropriate and applicable in a very remote location or with operators without a lot of technical background and experience? And our answer would be yes. The units, as I mentioned before, very reliable, very simple. If the customer is using the right quality of salt and is running the generator inside of its parameters and not bypassing alarms, the systems run themselves. There's very little preventative maintenance. We put a cartridge filter on the brine source and on the water source just to prevent any large solids. Changing that filter once a month, once every other month, is really the only preventative maintenance that our systems require. The systems are fully automated all the way down to the Ryozuni unit, so that if an operator mistakenly shuts the inlet valve, shuts the outlet valve, runs boiler condensate water into the unit and it's way over temperature, the system will shut itself down and give the operator feedback what alarm shut the unit down, and they can then go check for low inlet water pressure, high temperature, etc. So we would say yes, with very little training. The operations of MIOX on-site generator are almost as simple as a chemical feed pump. I won't portray that it's the same, but it's certainly closer to a chemical feed pump than a clarifier or a membrane system. This is a good question. So does MIOX have a registration with the EPA? And the answer is not with the EPA. We do have an NSF registration, but the EPA does not treat on-site generators as a chemical. And so the EPA's stance today is still that they will not supply a chemical registration number for a piece of equipment that makes a chemical. And so the answer is no, we do not have an EPA registration number as a biocide because of that stance of the EPA. They continuously are looking at that of, should they verify the product somehow. We primarily use the NSF as verification for safe to use with drinking water and all the wetted components. But we do not carry that EPA registration because they don't require us to today. If in the future the EPA decides to write a protocol and measure and certify on-site generation, then certainly we would go through that. Next question is operational costs and safety advantages of MIOX to other methods. I'll take the operational cost issue first. Depending on the application, whether we're looking at treating produced water that comes from an oil or gas exploration, or municipal wastewater, or municipal drinking water, all of them have alternate methods of disinfection, either multiple chemistries, UV, ozone. So it's really very specific on what the application is and what the alternative is. Our experience has been that if the customer is using more than one chemical, we are almost always less expensive. So if they're needing to use chlorine and bromine, or if they're needing to use chlorine and a periodic dose of a proprietary algicide, or if they're needing to use a quaternary compound and glutaraldehyde. In all of those cases, the MIOX on-site generated chemistry, even depreciating the capital over a relatively short period, will be cheaper. From a safety standpoint, we feel we're far superior to most all biocide chemistries from a safety standpoint, because the bulk ingredient is dry salt. And from a spill avoidance standpoint or a EHS handling standpoint, salt is obviously much safer than most of those biocides, even in dilute concentrations. And then even the output of the generator, because we produce at under 1% at a relatively neutral pH, the output of the unit is still safer in most cases, especially than gas chlorine, for example. So we see superior safety benefits and very often cost benefits for many applications. The applications where we don't see that is if the customer doesn't have a need or a push or an interest to move away from gas chlorine, and they have a relatively close chlor-alkali plant, then that solution probably would be less costly than our solution. Next question was on pretreatment for fouling control of seawater RO systems offshore. My background is actually more in membrane and desal. I've been at MIOX for about 2 years now. But prior to that, I was with GE Water and was very involved in membrane technology and desal. And we would say yes, we definitely think from a biofilm control standpoint on inlet piping, the MIOX chemistry could offer some real advantages. Today we don't have a full-scale system operating. We've done some pilots, but certainly are interested in talking with more customers about that biofilm removal. Now the MIOX chemistry is the heavy oxidant, just like another form of bleach, so it would need to be removed prior to the membrane system. But that if the membrane system is struggling with biofouling that can be traced back to organic material on the inlet screens or on the inlet piping, then yes, we definitely think we can bring some benefit there. So the next question was, how long can I store the generated solution? Again, this is a question that's very dependent on temperature and also what the output chemistry is. So if the output chemistry is standard sodium hypochlorite, the storage requirements would be similar to slightly better than bulk hypo. So certainly we would not recommend storing more than a few days. That when you're sizing the system and looking at usage, more than a few days is probably not optimum. Now if you have a relatively cold storage, perhaps you can get up to a couple of weeks, but it definitely is a product that is specifically designed to be generated and used on site, not generated and stored, or not generated and shipped to another site. Okay, I got another question on the difference between the mixed oxidant chemistry and straight sodium hypochlorite. We do get this question a lot, primarily because there are not other companies in the industry that are offering the mixed oxidant chemistry. And our opinion is that all electrolytic cells produce some form of other oxidants. Obviously, the primary oxidant out of the electrolytic process is sodium hypochlorite, but that our experience and our research shows us that all electrolytic cells produce a small amount of other oxidants, most measurable being most likely hydrogen peroxide. Where MIOX is different and unique is that in our early research, we spent literally years optimizing the electrolytic cell, changing the coatings, changing the spacing, changing the power supply, and measuring all of those parameters against each other to find the cell that actually produced the most mixed oxidant in addition to the sodium hypochlorite. And so it's not something we patented. It's actually proprietary information for the company, because if one of the other manufacturers in the industry chose to do that level of optimization and spent the millions of dollars that MIOX has, they could probably find the same secret formula. But it is something that is unique to MIOX today in the industry. Again, the differences between the mixed oxidant chemistry and the sodium hypochlorite is the design of the cell. We run the cells differently. We do some other things differently that I can't share, but it is a different design cell. And so if you were to buy a Rio unit, you need to specify up front if you want a mixed oxidant unit or a sodium hypochlorite unit, and you do also give up some capacity. So you give up about 20 or 30% output by volume when we make the mixed oxidant. And so that is a trade-off between the two chemistries. Why would an end user choose one or the other? Again, that's completely dependent on what their problem is. If chlorine is effective at doing the job of biologic control, but they simply need a lower cost form of chlorine or bleach, then we would recommend a hypochlorite generator. If for some reason the chlorine is not doing the job, not controlling biofilm, not getting the log removal that they need, then we would recommend the mixed oxidant and recommend the customer pay the premium, both in capital cost and operating costs, because the electrical consumption is also higher in a mixed oxidant generator. So, hope that answers the question, but there is a distinct difference between the two. The next question we get a little bit on oxidation of iron and manganese. And certainly the chemistry, just like chlorine, is effective at iron and manganese removal. We have some case studies where it was actually more effective. I would not portray that the MIOX chemistry is dramatically more effective. But certainly we have some customers, especially in very low dosages, not low dosages, but getting down to very low detectable limits. And so if the iron and manganese limit is very, very low, we have seen a couple installations where the mixed oxidant chemistry is able to react further and longer with some iron and manganese. But again, very application specific. Please reach out to us, and we'd be happy to help with, in the U.S., our partner Parkson, or one of our other partners around the world to help that application. Next question was, are we able to produce the product in different output concentrations? And the answer is yes, but we don't do it. And the reason is that it's not optimized. So that we could produce an output chemistry that is lower or higher, but the disadvantage is that both the capital cost of the system and, most importantly, the ongoing operating costs are actually not as optimized. And since you're taking the mixed oxidant or the sodium hypochlorite output and injecting it into another stream at a very, very dilute level, really it doesn't matter if your concentrated oxidant is at 0.5% or 1% or 5% or 10%. It's simply the size of the chemical feed pump that injects that fluid out into your facility, because we don't have any applications that use the chemistry at anywhere near that dosage. Probably the oil and gas segment's the area where we see the highest dosages, and even then they're only using 50, 80 milligrams per liter, which is, again, 100 times diluted to even our 1%. And so, we do have the ability to make a cell that does different outputs, but long term we don't find it cost effective for our customers. So we've targeted in on that 0.5% to 1%, depending if it's a mixed oxidant cell or a hypo cell. This is a good question. How often do the cells need to be replaced? The cells, if they have correct maintenance and are run correctly on the right quality of salt, we project life at 10 to 15 years. We guarantee the cell for 5 years. And so somewhere, I would say maybe 7 to 9 is the average life of the cell. It's also increasing. MIOX has been in the process of introducing new electrolytic cells, and we've reintroduced a number of the product lines over the last few years. So we're seeing longer life. So we can certainly go pull some data, but I would say maybe 6 to 7 years is our history, but the trend we're seeing in the future is going to be more 9+ on electrolytic cell life. I think the next question is on biofilm control and why does the MIOX product do a better job than standard hypo? And our answer would be yes, it's the other oxidants we're able to produce. We do not see the same level of biofilm stripping with our hypo product as we do with the mixed oxidant. And we have a number of customers, even the customer I was visiting last 2 weeks ago in Bogota, Colombia, where as they shifted onto the mixed oxidant chemistry, they actually saw visibly in a number of the distribution points organic material coming off the piping. We shifted the chemistry at a hot spring spa in Japan a number of years ago, and they literally had to take nets and buckets to scoop the organic material out for the first 2 weeks of transition. And so we have seen a number of cases on distribution systems that were chlorinated and shifted to a mixed oxidant chemistry, dramatic strip off of the biofilm. So the only explanation would be that the on-site generated chemistry does have those other oxidants that are better able to break down and remove that biofilm. Do we have operating cost comparison between MIOX and bulk disinfectant? We do have a good calculator for that. As I mentioned before, we have a pretty robust calculator that will compare cost of existing treatment with the MIOX solution. You can amortize the capital over a number of different years. Depreciation can change. Cost of money can change. And then obviously site to site, your cost of electricity and salt are the biggest drivers. And so what the economic payback is for a MIOX system is completely dependent on the site. Our experience is that the further away from a chlor-alkali plant, the shorter that payback. And certainly chemical programs that are having to use multiple oxidants have shorter payoffs. And so it really depends on what is a good payoff in your customer's mind. Our experience in the market right now is that probably less than 2.5 years, maybe 3 to 4 years in the municipal market is kind of the threshold for customers to take action. We also have a number of our service providers and partners that actually offer the product as a service. And so if a customer is paying $10,000 a month today for their chemical solution, often a portable unit can be put at that site and start saving money immediately. That we could do a monthly billing of $9,000 a month, and right from the first month, the customer is saving money, and we and our partner would look for some commitment, minimum commitment of a couple of years to make sure that we really had time to effectively treat, get the program running, use the asset. But yeah, that's another option. If the payback is potentially too long and the customer doesn't want to come up with capital on their own, we do have a number of service providers that offer lease options. And even MIOX is looking at, in a couple market segments, potentially getting into the lease market ourselves. Question about the reverse polarity. Is it an automatic feature or must it be manually initiated? It is an automatic feature. but we will change it at system commissioning. So as we're looking at your water chemistry with you and the potential quality of salt that the customer wants to use, we may set that reverse polarity differently on different systems. And it is a trade-off, because the reverse polarity does cause wear on the electrolytic cell. So our 5-year warranty, 9-year projected life is based on a certain number of reversals. If we have a customer that comes forward and says, I want to use this salt because I can get it for free, but that it's going to have higher hardness, we may up those reversals of the polarity at the expense of potentially shortening the life. So it's not something that needs to be manually initiated, and it's not even something that we can manually change in the field. It is hard programmed into our control logic. I got another question about frac water, and if waste brine water could be used as our source of brine, and the question is probably, or the answer is probably. Again, we're just starting that research now. We actually have a pilot running today on waste salt. The results have been very positive so far, but it's not a commercially available product today. I would say probably Q1 of next year. As long as the testing continues to be positive, we'll be introducing a product that would be able to be run on waste salt. And it most likely will have different attributes. To run on waste salt, we may change the warranty, we may change the expectation of life, excuse me, but certainly that is a product that's in development right now, including in frac water. I think we'll do just a couple more here and then wrap it up. And certainly, if some of your questions didn't get answered, please reach out to us directly. You can contact us through the website or any one of our service providers. MIOX is a technology company primarily, and so we work through different solution providers. As I mentioned, Parkson in the U.S. For the municipal drinking water market. We work with Schlumberger on a number of oil and gas businesses. Our partner in Colombia is USA Global Markets, who's done a great job with us with Bogota and some of the other water districts in Colombia. So certainly reach out to either one with your questions. We'll try and do a write-up and answer maybe some more of these questions on the posting that we do on the website. I'll try and take one more question here. So one last question, a good one that we'll wrap up with today. One of the outputs of the electrolytic process is hydrogen. So we do get that question very often of, is there a danger associated with it? How do we handle hydrogen? MIOX takes this issue very seriously, and we have done extensive research and work very closely with third parties to verify our designs and our recommendations on hydrogen safety. And we do have a very extensive white paper that we'll supply to anyone of interest on our recommendations to handle hydrogen venting, both off the generator and the oxidant storage tank. And if you have any questions on, we'd like to do this, or we'd like to modify that, or another manufacturer said we should do hydrogen venting this way, please reach out to us directly. As I mentioned earlier, we have thousands of units installed around the world, and we have never had a hydrogen incident. And so we take it very seriously, and we'll put a lot of time and energy into helping our partners and our end users ensure that the hydrogen is handled and vented safely. We do get the question once in a while of, can the hydrogen be used? The answer is no. The volume we produce is enough to make sure it's handled effectively and safely, but not near enough to actually be captured and used for any beneficial purpose. So with that, we'd like to wrap it up. And again, if you have questions, please reach out to us directly. Take care.